Welcome to our course Formal Language and Automata Theory. In this lecture, I'm going to explain about construction of a PDA for a given context-free language. So here I have taken one example problem. So read the question. Obtain a PDA to accept the language. The language is L of M equal to W such that W belongs to A plus B whole closure and N suffix A of W equal to N suffix B of W by final state. So what is the meaning of N suffix A of W and N suffix B of W? That is nothing but number of A's in string W should be equal to number of B's in string W. So here this condition needs to be satisfied by the language L of M equal to W such that W belongs to A comma B whole closure. So here let us see the solution step by step. The language accepted by the mission should consist strings of A's and B's of any length. So here in the language definition, they have given W belongs to A plus B whole closure. That means the string is combination of AB including null. By repeating AB once or several times, you will get a set of strings. So whatever the string you are taking from AB combination with any length is allowed. But the only condition is whatever the string you will consider, in that string number of A's should be equal to number of B's. That is the only condition needs to be satisfied. So here the only restriction is that the number of A's in string W should be equal to number of B's in the string W. So this is the only condition needs to be satisfied. Whereas the order of A's and B's is irrelevant. So any order, your string may start with A, your string may start with B. Any order is allowed. But finally, the string consisting of equal number of A's and equal number of B's in any order. So total number of A's in the string, then total number of B's in the string should be equal. That is the only condition needs to satisfy the given language. For example, so let us take, so null is also allowed, epsilon, then the string AB. AB means here 1A, 1B. So the length is 2, or because two symbols are there. Then BA reverse. Just now we mentioned the string may start with A or may start with B, any order. Here order is not important. The only restriction is the number of A's should be equal to the number of B's. That is the condition. Then another string, so 3A's, 3B's. Then another string ABA, BAB. Then another string AA, BA, BB, etc. Are all the strings in the language L of M. So every string you can observe the condition. So null, okay, null default allowed. Now AB. So in AB, number of A's are 1, number of B's are 1. So number of A's equal to number of B's. Then BA. So number of B's are 1, number of A's are 1. So both are equal. Now in this you can observe here 3A's, 3B's. So here mod A, the length of A equal to 3, then mod B equal to 3. That means number of A's are 3, the number of B's are 3. Therefore, number of A's should be equal to number of B's. So this condition needs to be satisfied. Then here you can observe, here first you can count A's 1, 2, 3. So here also mod A equal to 3, number of B's are 1, 2, 3. So therefore, mod B equal to 3. Here also number of A's is equal to number of B's. Now next string you can see. First count A's 1, 2, 3. Here also mod A equal to 3. The number of B's 1, 2, 3. Here also number of B's are 3. Therefore, number of A's should be equal to number of B's. But here you can observe, here we are not concentrating on the order of the strings. So here first started with A, here started with B, here started with A, then here AB, here AA, like so any order is allowed. but only the condition the length should be equal for both A's and B's. So this is the nature of the long ways. So only the mission, whatever the mission we are going to construct, will accept only these type of strings. Now let us see the general procedure what we will follow here. So we don't have a standard procedure. Problem to problem, the procedure is changed. So the first scanned input symbol is pushed onto the stack. So now whenever you are scanning an input from the input tape, so that should be pushed onto the stack. So the scanned input symbol may be either it may A or it may B. Why? Because the string may start with A or may start with B. So any symbol that you can push onto the stack. So then from this point onwards, if the scanned symbol, that means input, is same as the symbol on the stack. So that means the input and the symbol on the top of the stack, so is equal, then what you have to do? You have to push the current input symbol onto the stack. Then if the input symbol is different from the symbol on the top of the stack, so that means if input is A, let assume, then top symbol is B, or reverse, if input is B, the top symbol is A. So reverse symbols are there. So at that time we have to pop one symbol from the stack and repeat the process. So this is very important. First you have to scan any input symbol onto the stack. It may be either A or B. Next time, if your input symbol is same as stack top symbol, then you have to push. That means if input is A, stack top is A, you have to push. If input is B, stack top is B, you have to push. So then whenever opposite symbols occur, that means if the input symbol is different from the symbol on top of the stack, that means if input is A, stack top is B. So A, B, both are different. You have to pop. Then reverse, if input is B, then stock top is A. So both are reverse. So then we have to perform pop operation. Then after performing push and pop operations, finally, so when end of string is encountered, that means if the stack is empty and the string W has equal number of A's and equal number of B's. So whenever end of string is encountered means the input is empty, then the stack is empty, means it contains the initial symbol Z0. So whenever this was occurred, then we can say the string W has equal number of A's and equal number of B's. Suppose this condition is not satisfied, input is not empty or stack is not empty, or input is empty but stack is not empty, or if input is not empty, stack is empty. If anyone not satisfied, that is otherwise. So the number of A's and number of B's are different. So this is the logic we have to apply in this problem. Now we will see step by step. So in step 1, so first let us take Q0 as the initial state or start state, and Z0 be the initial symbol on the stack. So these two you can assume initially. When the mission is in state Q0, when the mission is in state Q0, that is initial state, and top of the stack contains Z0, that is stack contains only initial symbol on top of the stack, then what you have to do in this case, we have to scan the input symbol. Scan the input symbol. So the input is either A or B, just now we mentioned. So the string may start with A or may start with B. That's why here input symbol either A or B. So you have to consider both cases. Then what you have to do, you have to push it onto the stack. So if input is A, the stack initial symbol is Z0, then you have to push A onto the stack. Then if input is B, then a stack initial symbol is Z0, then you have to push B onto the stack. So now the transitions defined for this can be of the form. Now what are the transitions? So here first let us see the diagrammatic representation. So first case 1. So here the stack initially contains a start symbol Z0. So then if input is A, then you have to push A onto the stack. Then case 2, same stack content Z0 is the initial symbol. Then if input is B, then you have to push B onto the stack. So here in this case, here we have to push A onto the stack. In case 2, we have pushed B onto the stack. Now for this, the corresponding transitions are. So for the first case, the transition is defined as now delta of we are at Q naught. Now your input is here A. Now the stack initial symbol is Z naught. So now here don't change the state. So the machine remains in the same state Q naught. Now A is pushed onto the stack that will be placed at the top of the stack. Now A, now Z naught remains same. This is the transition corresponding to case 1. Similarly, case 2, now we are at same state Q naught. Now input is B here. If input is B, then stack contains only the initial symbol Z naught. Then without changing state, you have to push B onto the stack. Now this is the corresponding transition for case 2. That means the string may start with A or the string may start with B. That's why both cases we have to consider here. That is step 1. Then coming to step 2. So now in the previous step, we have scanned the first symbol that is either A or B, then that can be pushed onto the stack. Now, once the first symbol is pushed onto the stack, then the top of stack may contain. Now, what top of stack contains? See here in the above case, we have pushed A onto the stack. Now, top of the stack is A here. Then whenever B is pushed onto the stack, then top of the stack is B. That means top of the stack is either A or B. So both combinations are there. So now once the first symbol is pushed onto the stack, the top of the stack may contain either A or B. So both cases are allowed. And the next input symbol to be scanned may be next time again. So the input may be again either A or B. So if the input symbol is same as the symbol on top of the stack, that means if input is A, then top of the stack is A. Then what you have to do? Push the current input symbol onto the stack, and it remains in state Q naught only. Otherwise, pop an element from the stack. That means when you have to perform pop operation, if the input is not same as the top of the stack. So here, if input symbol is same as the symbol on top of the stack, we have to push. Again, here two cases. If input symbol is A, top of the stack is A, then you have to push A onto the stack. Second case, if input symbol is B, then top of the stack is B. So both are same. Then you have to push B onto the stack. So only the input and top of the stack should be same. Then only you have to perform pop operation. Otherwise means if input is A, then stack top is B. Both are different. Or if input is B, stack top is A. So both are different. In this case, you have to pop an element from the top of the stack. Now for this, the transitions defined for this step are given below. So now here again, what we mentioned. So here the case 1 you have to consider. So already your stack contains A on top of the stack. Then case 2, it contains B on top of the stack. So now if input is A, if input symbol is A, then push A onto stack. Now the corresponding transition is, here we can't change the state, still remains in the same state Q naught. If input is A, then stack top is A. Without changing state, simply you have to push the current input. Now this is the new input pushed onto the stack, which can be placed on top of the stack. So here A is pushed. Similarly, if input is B, then push B onto the stack. That means already stack top contains B here, second case. So then input is also B. That means input is same as stack top. Then you have to push. For this, the transition is delta of Q naught. Input is B, stack top is B. Then without changing state, simply we have to push B onto the stack. Now this is the symbol B pushed onto the stack, which can be placed on top of the stack. So earlier symbol, previous symbol remains same. That will be moved down to the stack. So now in the previous step, here we have two transitions. So then these are all remaining two transitions. You can give numbering. So now 3, 4. So now this is okay. If input is same as stack top symbol, then only you have to perform push operation. Otherwise pop. So otherwise pop means if input is different from the top of the stack. So now the next transition is, so suppose here your input is A, then stack top is B. So both are different. So both are different. So in this case, what you have to do without changing state. So now simply here you have to perform pop. So this is nothing but pop B. Why? Because B is on top of the stack. So how can you perform pop? By using the empty string, that is epsilon. Similarly, if reverse input is B, stack top is A. So both are different. Here also you have to perform pop. Now here we popped the top symbol of the stack. What is the top symbol? A. So if the above case 1, case 2 not satisfied, otherwise we have to perform pop. These two cases we have to perform pop. That is, if input is A, stack top is B. If input is B, stack top is A. So in these two cases we have to perform pop operation. So these are all corresponding transitions related to step 2. Here, two operations we performed, push and pop operation. Then coming to next step, third step, here you can see. Now still we are in state Q naught only. Now if the next input symbol to be scanned is empty, now all inputs are scanned. Now next input symbol to be scanned is empty, that is empty string denoted by epsilon, and top of the stack is Z0. That means here the input is empty and top of the stack is Z0. It means that for each symbol A, there exists a corresponding B. So whenever input is empty, stack contains the initial symbol as Z0. So what is the meaning of this? For each symbol A, there exists a corresponding B, and for each symbol B, reverse, and for each symbol B, there exists a corresponding symbol A. That means, so this is nothing but the condition of equal number of A's and equal number of B's. The order is irrelevant here. So now, so the string W now consists of equal number of A's and equal number of B's, and change the state to Q1 here. Now here Q1 we will call it as the final or accepting state. Now the transition defined for this can be of the form. So here what is the case? Here the stack is empty. That means it contains only initial symbol Z0, and input is epsilon. That means empty. Then stack contains Z0. Then the corresponding transition is, now we are at Q0 state only. Input is empty, that is epsilon. Stack contains initial symbol, that is Z0. Now we have to change the state Q1. Now the stack remains empty only. So here we can say Q1 belongs to F, which is a final state. Now this is seventh transition. So now this is the final. So this is acceptance case. This is acceptance case. So now here we have performed push and pop operation. Then the first step we performed only push operation. So any PDA consisting of push operation, pop operation, then acceptance case. So this acceptance case is common for all PDAs. So in the previous step, whatever the your current state with empty input, with empty stack, it goes to final state, then the stack remains same. So now finally you can write the PDA, whatever the PDA we obtained here. So you can write the PDA with all tuples. So the PDA to accept the long ways, to accept the long ways. Here, what is the long ways? The given long ways L equal to W such that W belongs to A plus B whole closure, and the condition is number of A's in string W equal to number of B's in string W. So this is the given language. Now the corresponding PDA is, so is given by, first write down the tuple definition. So given by M equal to Q sigma tau delta Q naught Z naught F. So the 7 tuples, where write down all the tuples, where Q equal to, what are the states we used here in the 1 to 7 transitions? So we used only 2 states, that is Q naught and Q1. Now sigma equal to, in the given language itself. So here W belongs to A plus B whole closure. So here sigma is nothing but A comma B. Then tau equal to stack alphabet. So what stack contains, in the right hand side of each and every transition you can see whatever the symbols it contains, those are all stack symbols. So here A is there, B is there, but don't consider null as the stack symbol. So A, B, then Z naught also there. So these three are the stack alphabet. So A comma B comma Z naught. So then what are the other tuples? Now Q naught belongs to capital Q, is initial or start state. Initial or start state. Then Z naught is there. Z naught belongs to tau, is initial symbol of the stack. So initial symbol of stack. Now what is the other tuple remained? Delta. So and delta is shown below. Now write down all the 7 transitions. The above 7 transitions you have to write down. That is delta. So the first transition is delta of Q naught A Z naught equal to Q naught A Z naught. The second transition delta of Q naught B Z naught equal to Q naught B Z naught. So these 2 transitions related to step 1. Then the third transition delta of Q naught A comma A equal to Q naught comma AA. Then fourth transition delta of Q naught comma B equal to Q naught comma BB. So these 2 are push operations in step 2. Then we have pop operation also. Then delta of Q naught AB, opposite symbols are occurred. Then Q naught comma null, pop operation. Then reverse, delta of Q naught comma B comma A equal to Q naught comma null. So these 2 are related to pop operation. Then the last step transition, that is acceptance case. Q naught, delta of Q naught comma epsilon comma Z naught equal to Q1 comma Z naught. So these are all the 7 transitions what we obtained. Then here the last tuple, final state also write down. So and F equal to Q1 is final state or accepting state. Now this is the final PDA. Now draw its transition diagram also. Transition diagram of PDA for the above PDA. So here we have only two states. The first one is Q0. The second state is Q1. Now Q0 is the initial or start state. Draw an arrow. Then Q1 is the final state. Represent within a double circle. Now include all the transitions. So first one is Q0 A Z0. It is going to Q0 itself. So now all are self loops here many. So you can make self loop one by one. You can include first Q0 on A. Then what initially stack contains here Z0 is there. Then after the move, it contains A Z0. That you can represent separated by comma by using R. So Z0 by A Z0. Then second transition Q0 on B, stack contains Z0. Then after move, stack contains B Z0. Then input is A. Then the stack top is A. Then the stack contains AA. Then input is B. Then stack top is B. Then BB will be on the stack. So these are all the transitions. See Q0 on A, Z0, Q0 on B Z0, Q0 on AA, then Q0 on BB. So same state. Then with pop also same state. Q0 AB. So fifth and sixth transitions also going to same state itself. So now input is A. Now here stack top is B. Then B is erased here. So by null. Now input is B. Stack top is A. Now this is erased by null. Now you can see fifth and sixth transitions also included. Then the last transition Q0 with empty string with the initial symbol of the stack Z0, it is going to Q1. So now here Q0 to Q1, here input is empty, that is null, comma, the stack contains Z0 initially. Then after the move, it contains same Z0 only. Now this is the PDA transition diagram for the above PDA. So now you can verify whether this mission is correct or not. So by taking one string, so you have to check the acceptance. So therefore, let us check the string to accept the string. So let us take any string. For example, A, B, B, A, A. So to accept the string A, B, B, A, A. See here you can see whether this string satisfying the given language. Let us check. Here number of A's 1, 2, 3. Number of B's 1, 2, 3. So number of A's should be equal to number of B's. That means this string compulsory should be accepted by the constructed PDA. So if it won't accept by the PDA, then our problem is wrong. So let us check. Now the sequence of moves made by the PDA for the string ABBAA is shown below. First, we have to take the initial configuration with initial state, the given complete string followed by the initial symbol of the stack. So this is called as initial configuration. This we already discussed the acceptance of strings by PDA. So this is initial configuration. So now substitute the corresponding transitions by using the above PDA. Q0 A Z0. Here what you will get same state. The remaining input after scanning A, the remaining input is B B B A A A. Now Q0 A Z0, the first transition. A is pushed onto the stack. Next current state is Q0. Current input is B. Then current top of the stack is A. Now see Q0 BA, what is the transition here? So Q0 BA, the sixth transition. So same state here, top of the stack is erased. So Q0 null. So here pop operation. Now what you will get here Q0. So the B is scanned, remaining input BBAA. Now A is deleted from the top of the stack. Then the stack contains only initial symbol. Next again Q0 B Z0. So this is the second transition. So B is pushed onto the stack without changing state. So Q0, the remaining input is BAA. Now B is pushed onto the stack. So B Z0. So now next you can see again here what you are getting The current state is Q naught, current input is B, current top of the stack is B. So the input and stack symbol is same. So then we have to perform pop operation using the fourth transition. Delta of Q naught BB equal to Q naught comma BB. So we have to push B onto the stack. Now this will becomes Q naught. Now the remaining input is AA. Now B is pushed. Remaining previous B remains same. So now Q naught AB. Now you can see the input and stack top both are different. So you have to perform pop. So Q naught AB. So what is the related transition? Fifth transition. Q naught AB equal to Q naught null. That means erase. So then now the state is same Q naught. The remaining input is A. If one B, which can be at top, is erased, then the remaining B remains same. Now it contains B Z naught. Again Q naught AB, same input and stack top both are different. You have to perform pop. Now Q naught. After scanning A, then input is empty. Now after erasing B, the stack contains only Z naught. Now you can see your state is Q naught, input is empty, stack contains initial symbol. The last transition, that is acceptance case, delta of Q naught epsilon Z naught equal to, it is going to Q1 state, then the stack remains same. Now the state is Q1. Now the stack contains Z naught. Now here you can see where Q1 belongs to a final state. Therefore, the string is accepted by the PDA. Therefore, the string, what is the string here? A B B B A A is accepted by the PDA what we apply. So therefore, the machine accepting the strings derived from the language satisfying the condition of equal number of A's should be equal to equal number of B's. So this is the final solution. Now let us review once. So here this is the given language L of M equal to W such that W belongs to A plus B whole closure and number of A's in string W is equal to number of B's in string W. So as for the nature of the language, what it contains equal number of A's and equal number of B's of any length. Here the only restriction is the number of A's in string W should be equal to the number of B's. The order of A's and B's is irrelevant. So now the general procedure what we used here. First we have to scan the input symbol that can be pushed onto the stack. The input should be either A or B. So simply we have to push those symbols onto the stack without changing state. So next step, once the first symbol is pushed onto the stack, then the top of stack may contains either A or B. And the next input symbol to be scanned may be again either A or B. So in this case, if the input symbol is same as the symbol on top of the stack, we have to push the current input symbol onto the stack and remain in the same state only. Otherwise, we have to pop an element from the stack. So that means if input is A, then your stack top is also A. Then you have to push A onto the stack. Then second case, if input is B, then stack top is also B. Then you have to push B onto the stack. Otherwise, you have to perform pop operation. That means if both are different, the input and stack top are different, we have to perform pop. So that is, if input is A, then stack top is B. So both are different. So we have to perform pop without changing state by using null, that is epsilon. Then if input is B, stack top is A, both are different. So you have to perform pop without changing state. So then finally, the machine is in state Q naught. Then the next input symbol to be scanned is empty, that is null. And the top of the stack is Z naught. It means that for each symbol A, there exists a corresponding symbol B. And for each symbol B, there exists a corresponding symbol A. So finally, the string W consists of equal number of A's and equal number of Bs and change the state to Q1. Now this Q1 is called as the accepting or final state. Now for this the transition is so delta of Q naught comma epsilon comma Z naught. Here input is empty, then stack contains Z naught, that is initial symbol. Then it changes to state Q naught to Q1. So then the stack remains same empty, that is Z naught. So where Q1 belongs to F, which is a final or accepting state. So then the final PDA to accept the language is shown below with 7 tuples. Then all tuple values are listed here, including transitions. Then transition diagram is also constructed here. Then finally, we have verified one string, so which can be derived from the language. Then the string is accepted here. So this is the final solution.